In this video, we extend our understanding of stoichiometry using limiting reactant scenarios, where we are given the starting quantities of more than one reactant, and we have to determine which reactant will run out first, or in other words, which reactant is the limiting reactant. We're going to discuss excess reactants versus limiting reactants using the mole interpretation of the combustion reaction between hydrogen and oxygen to produce water. And here we see a balanced chemical equation to represent this simplest of combustion reactions. The mole interpretation of this equation says that 2 moles of hydrogen will react with 1 mole of oxygen to produce 2 moles of water. Now typically we won't start with exactly 2 moles of hydrogen. We might, for example, start with 4 moles of hydrogen, in which case the mole interpretation would say that we now require 2 moles of oxygen and that we would actually produce 4 moles of water. If we were to start with 10 moles of hydrogen, we would require 5 moles of oxygen and we would produce 10 moles of water. Now these numbers here, the 2, 4 and 10, and the 1, 2 and 5, and the 2, 4 and 10 are in the same ratio or same proportions as the stoichiometric coefficients in the balanced chemical equation. But what happens if we are not presented with reactant amounts in the same proportions? For example, imagine we started with 10 moles of hydrogen and 7 moles of oxygen. How many moles of water would be produced? We can represent that scenario using these diagrams here. Before the reaction, we can say that we've got 10 moles of hydrogen, represented, for example, by these 10 hydrogen molecules in white, and we have 7 moles of oxygen, represented by these 7 molecules of O2. What actually happens after the reaction is that we still end up with our 10 moles of water produced, but we will also have 2 moles of oxygen left over. In this case, oxygen is said to be present in excess, and hydrogen is said to be the limiting reactant. It is the reactant that is completely consumed. Once the hydrogen runs out, the reaction cannot continue because there is no more fuel for this combustion reaction, and any excess oxygen just remains unreacted. It is important that we identify which reactant is going to run out first, or which reactant is the limiting reactant, because the moles of product, in this case water, will always be determined by the starting moles of the limiting reactant. So our 10 moles of hydrogen plus our 7 moles of oxygen will still produce our 10 moles of water, and that's because the oxygen was considered to be in excess. The limiting reactant in this scenario was hydrogen, and the moles of product are therefore determined by the starting moles of hydrogen. Let's change the scenario slightly. What if we started with 10 moles of hydrogen again, but this time we only had 3 moles of oxygen available for reaction? How many moles of water would be produced? We can represent this scenario again here, where we have our 10 moles of hydrogen being represented by these 10 hydrogen molecules, and our 3 moles of oxygen being represented by these 3 molecules of oxygen. And what we find is that there is only enough oxygen to be able to produce 6 moles of water molecules, with an additional 4 moles of hydrogen molecules left over. So in this case, hydrogen is said to be in excess, and oxygen is said to be the limiting reactant. It's the reactant that runs out first, and even though there is hydrogen still available for combustion, it cannot combust because there is not enough oxygen to react with it. And again, it is important to note that we need to identify the limiting reactant because the moles of product will always be determined by the starting moles of the limiting reactant. So in this second scenario, we started with our 10 moles of hydrogen, but we only had 3 moles of oxygen available for combustion, and then that produced only 6 moles of water. Mathematically, we can represent this scenario by stating that the moles of water produced equals 2 divided by 1 times the starting mole of oxygen, since oxygen has been identified as the limiting reactant. The 2 comes from the stoichiometric coefficient of water, the substance we are trying to find information about, while the 1 comes from the stoichiometric coefficient of oxygen, the limiting reactant, which we have been given information about. And we multiply that 2-on-1 ratio by the starting moles of oxygen, which is 2 divided by 1 times 3 moles, which equals our 6 moles of water being produced. And what you will note here in this mathematical expression is that we've completely ignored the 10 moles of hydrogen, since that is the substance that is present in excess, whereas the moles of product is only determined by the starting moles of the limiting reactant. In subsequent videos, we will demonstrate how to apply the limiting reactant concept to real examples and scenarios.